Good morning, students. Welcome to the virtual classrooms. We are studying chapter number 8, redox. In our last lecture, we studied related to half reaction method, balancing the redox reaction by half reaction method. Today, we will be doing it by oxidation number method. What the change we are going to get it is only in the first, second step. Rest all the steps are going to remain as same as what we did it in half reaction method. Only the change that we are going to get is in the initial steps. Right? We will understand it even for the first reaction. I will write it what I have to do it in the step 1, what I have to do it in the step 2, what I will do it in the step 3. All the initial headings that I will be indicating it for your first reaction. Same things we will do it by the second reaction also. Right? Balancing the redox reaction by oxidation number method in basic medium. Right? Every time I am taking it as in some new reaction. Last time we did it, then 2 reactions. I am not taking those 2 reactions. Already I told you in that last video also that those 2 reactions can also be balanced by this method. Both the reactions, I did it one in acidic, I did it another one in basic. In place of that, both those reactions by oxidation number method, both in basic medium, both in acidic medium can also be balanced. Right? So you can take those 2 reactions also as an example and make a practice. I am going to do it to these reactions in oxidation number method. You can take both those reactions and do it by half reaction method also, both in acidic as well as in basic. That means total we did it as an only 4 reactions, but actually you can say that we did it as an 16 reactions, because each reaction can be done in half reaction acidic, half reaction basic, oxidation acidic, oxidation basic. Each reaction, such type of 4 reactions we did it. Right? So if you do it each of those reactions as a practice, it will be much helpful to you. Right? Without practice, it's going to be difficult. Right? I want to balance the today's reaction, that is we will be having it as the reaction as the reaction that I want to balance it. Right? Now, step 1. Calculate the oxidation number of each element and find out oxidation and reduction reaction. Right? See, in half reaction method I told that we want to separate them. Here I am not going to separate, I am going to only specify them. That means, first of all, P4, OH minus, PS3, HPO2 minus. What is the oxidation number? Element, it's a molecule. P4 is a molecule. Oxidation number 0. Oxygen minus 2. Hydrogen plus 1. This one you are going to get it as minus 3 plus 1 plus 1. This one also plus 1 and minus 2. We will be having here 4 minus 4 plus 1 minus 3 minus 0 and plus 2. We are going to get the reaction as 8. Right? You know it how to calculate it. If necessary, you can make it like this: C plus 1 x 2 into minus 2 equals to minus 1 right? You can calculate it. We have already studied in our lecture how to calculate the oxidation numbers, right? So for each and every element I got that oxidation number. Okay. Now, what does it show? I want to find out which one went for oxidation, which one went for reduction, right? This P4 shows you it gets converted from 0 to -3. So this is known as reduction, right? Okay, -2, -2, +1, +1. So change is again for P4 itself is changing to +2. So this is oxidation. This is my oxidation of cell. See, we wrote it separately in our half reaction method. That P4 changes to PS3, P4 changes to this. In place of that, what I have to do is simply by putting an arrow mark on it, and I have to specify which one is oxidation, which one is reduction. That is my first step. Right? Now, step 2. Balance the element which show change in the oxidation number, and then calculate total electron transfer. That means again now what I will have to do is I will have to run that reaction P4 OH minus PH3 HPO2 minus, this one was reduced, this one was oxidized. I got it from the same element. For my simplicity, for making the calculation or for making my reaction non-errable, I am going to write this P4 again. Right? It was a P4 through which it went, so I am writing the same P4 again, so that it does not make my calculation complicated or dull, makes me to balance my reaction easily. So I am putting this as an oxidation, this as reduction. How many phosphorus are there? 4. For these particular 4 are there, so I am putting it over here also 4. See, if I would have not written this, you would have written 4, you would have written here also 4, but total 4 are there, here would have become 8. So that would be a non-balanced. And we want to balance that spectrum. Again, these P4, I can't put it over here, 2, here, 2. That also not sure. It may be 1, 3, 3, 1. Right? So that is a possibility. So what we made it for the simplicity, we made it as a separate object. Right? And the second now, electron transfer. This was 0, this was plus 2. So 0 to plus 2 means 2 electron transfer. How many phosphorus are there? 4. So that means 8 electron transfer. Right? Similarly, 0 minus 3. Each phosphorus transfer 3 electrons. How many are there? 4. So that means 12 electron transfer. Right? That is your second step. Step 3. Balance the electrons by that means now it's the same as half reaction. I have to multiply this one. If it is 12 or 8 for simplicity. For simplicity, I know it's a 4, 2 is 8, 4, 3 is 12. So in place of this, I can put it 2, I can put it 3. That will also do. Right? If you don't know the mathematics, put it equal, straightforward, and go forward. If you are aware about it, find out the simple values. So So you will be getting multiplied this equation by 3p4. This one is multiplied by 2p4. Nothing is specified for this. This is my spectator error. Nothing is indicated for it. I am going to write it as simple as OH minus. Again, this has to be multiplied by 2. This has to be multiplied by 3. Okay? We get it as 3p4 plus 2p4 OH minus 8p is 12HPO 2 minus. Now, step 4. It's going to be the same. Step 4. Balance the spectator. Now, this is known to me. I want to go for basic. So, I am going to balance my charge by OH minus. Okay. So, what we are going to get is 5p4 OH minus 8pH3 12HPO2 minus. Right. In this case, what is there? Except oxygen, hydrogen, we are removing it. So left out phosphorus is balanced. So I want to go for charge 0, minus 1, 8, minus 12. Right? So what I want here? 12 as a minus charge. So if I multiply it by 12, I get it 12 OH minus. So now the charge is balanced. The charge is balanced. Step 5. Balance the oxygen by H2 and then check the reaction. 5p4 12OH minus 8pH3 12HPO2 minus. Now what does it show? 12 oxygen, 24 oxygen. So there is a deficiency of 12H2. There was a deficiency of 12H2. So we get 12H2 over here. Now let's check what we are going to get. Phosphorus, hydrogen, oxygen, charge. Phosphorus, hydrogen, oxygen, charge. For the LHS, 20, 20. Hydrogen, 12 to the 24 plus 12, 36. H24 plus 12, 36. 12 plus 12, 24, 24. Charge, minus 12, minus 12. So that means we got it as balanced reaction. Right? Got it everyone? For the oxidation number method, your first 2 steps. What we did it for the half reaction, we separated them. Here we won't separate them. Let it them together. Right? Okay, rest everything has to be done in a simpler method. Same method. Now we will do it one more reaction. And we will do it quickly and compress it into a acidic medium. Right? Now this time again, I'm not going to write the headings of the step 1, step 2, step 3. You know it. Headings are going to remain same. Right? I don't want to waste my time for writing the headings. The reaction we are having it. N2H4 ClO3 minus. It gets converted into NO plus Cl minus. Right? See, hydrogen is not there at all. If you go for the trial and error, as we know it, that we can do it by the help of trial and error. If you try to go for trial and error, what will happen? Hydrogen won't be balanced at all. Because we don't know that I want to add H2O on this side or on that side, N2H4 ClO3 minus NoCl minus. This one will become as plus 4, so this one will become minus 2. This one will become plus 1 for each. This one will become plus 5 minus 2 plus 2 minus 2 minus 2. So this time what happened? I got it two separate reactions. Oxidation, reduction. The previous one was disproportionate reaction. Same element went for oxidation, same went for reduction. This is not here. The elements that is going for oxidation or the element that is going for reduction are different. It's an oxidation, that means this is going to act as oxidizing agent. This is reduced, so this is going to act as reducing agents, right? So step 2, we want to balance that element which shows the change in their oxidation number. That means I want to balance nitrogen and chlorine. N2H4 ClO3 minus NoCl minus. 2 nitrogen are there, so 2. 1 chlorine, so that is balanced. Now I want to go for electrons. Total electron transfer. I will have to specify the electrons also. Minus 2 plus 2. So how many electron transfer? 4. Don't say it's 0. I am not going for addition. I am going for minus 2 plus 2. How many electron transfer will be required? 4 electrons, not 0. Right? For each nitrogen 4. So total 8 electrons. Similarly, plus 5 to minus 1. Electron transfer, good. It will be 6 electrons. Right? So, when you are having a problem for such type of numbers and if you don't understand it, plot and number line. You know it. 0, minus 1, minus 2, minus 3, or plus 1, plus 2, plus 3. We are writing like the number line. From there, you want it as minus 2 to plus 2. How many transfer? 4. You can check it like that on the number line also. But that is for those students who can't calculate it orally. If you can straight away get the answers. Right? So here 8 electrons are required, here 6 electrons are required. Right? Okay. Step 3, I want to balance the reaction. How I am going to balance it? This time multiplied by 6, multiplied by 8. 2 is common for it. So in place of that I am putting 3, I am putting 4. That is the common number that I have simply removed. So what will happen? Step 3. We will be having it as a 3 N2H4 plus 4 ClO3 minus multiplied by here 3 2s are 6 NO plus 4 Cl minus. Okay, so we got it as the after cross multiplication of electrons that are balanced. Now step 4, what I want to do it is I want to go for balancing of charge. So what is the charge over here? 0, minus 4, 0, minus 4. So that shows that charge is already balanced. Right? So I don't need even H plus for balancing it. In the given reaction, charge is balanced. So we are going to get it as the same reaction in the step number 4. We are having same reaction. Right? Step 5. We want to balance now oxygen. 12. Here 6. So So that means the efficiency of 6 oxygen on RHS. So we will be having 3 into 4 ClO3 minus 6 NO plus 4 ClO plus 6 H2O. Right? Now let's take the component: nitrogen, hydrogen, chlorine, oxygen and charge. Or LHS, RHS. 3 to the 6 nitrogen, here also 6 nitrogen. 3 4 are 12 hydrogen, 6 to the 12 hydrogen. 4 chlorine, here also we are having 4 chlorine. 12 oxygen, 6 plus 6 12 oxygen. Charge -4 -4. If you are getting this as perfect, that means the reaction is balanced. If anything is different over here, make it sure that you don't go it for the same reaction, finding it out your mistake. Cancel it, do it again, because where you made an error won't be able to be rectified or won't be able to find by you. So make it sure that you don't waste the time, go for the balancing again. And in that case, my very first thing is check the oxidation numbers that are calculated correctly or not. Right? That's what we are having it for the redox reaction. Rest of the part of the chapter is being cancelled for our syllabus. So after the completion of all our chapters as per the syllabus, if time permits, we will go through those topics. Till then, thank you. From our next lecture, we will be starting with the chapter number 10. Right? Till then, thank you.